You know how we're always looking for the quick route to understanding something really big?
Oh, yeah.
Well, today we're staring down the barrel of a truly cosmic idea, like universe-level big.
We are. Prepare for maybe a shift in how you think about the ultimate stability of, well, pretty much everything.
Exactly. Forget just black holes for a second. This brand new research, it just came out May 25th, 2025. It builds on Hawking's work, but throws a curveball.
A big one.
So our mission today, let's try and get our heads around this new perspective on how the universe might just, well, fade away eventually.
Okay, so the core finding basically is that this process, Hawking radiation,
Right, the black hole evaporation thing.
exactly that. The theory where even black holes slowly lose mass over incredible timescales, this study suggests that might not be just a black hole thing.
Okay, hang on. So for anyone maybe not up to speed, just quickly, what's the gist of Hawking radiation?
Right. Simply put, near a black hole's edge, the event horizon, quantum mechanics allows tiny particle pairs to just sort of pop into existence. Virtual particles. Sometimes one gets pulled into the black hole, but the other escapes. And that escaping particle carries away a tiny bit of the black hole's energy, its mass.
Over like eons and eons.
Over unimaginable amounts of time, yeah. So the black hole slowly shrinks. It evaporates.
The ultimate vanishing act. Okay.
Yeah.
But this new study is saying this. Leakage. It's not exclusive.
That's the proposal, yeah. These researchers think similar quantum effects could happen around other extremely dense objects, things like neutron stars, white dwarfs, driven by their intense gravity fields even without an event horizon.
Wow. Okay, neutron stars and white dwarfs. These are the super dense cinders left over when stars die, right?
That's them, the cosmic leftovers.
And we always thought they were, pretty much permanent fixtures, like the end of the line.
That's definitely the standard picture. I mean, they're incredibly stable objects. Neutron stars have matter squashed so tightly, protons and electrons have merged into neutrons. White dwarfs are also super compact. But this research suggests that maybe even that extreme density, while not forming a true horizon, could still trigger these quantum fluctuations, cause a gradual emission of particles over these vast, vast timescales, a kind of Hawking-like radiation.
So, okay, here's the bit that really makes your head spin. If these things, these supposedly eternal embers, are also slowly fizzling out, what does that mean for the ultimate fate of the universe?
Well, if this theory holds water, the long-term outlook gets even bleaker. Starker, maybe?
How so?
It implies that, given enough time, essentially all matter, no matter how stable it seems to us now, could eventually dissipate through this kind of process.
So the universe wouldn't just get cold and dark and spread out.
Right, it wouldn't just expand into emptiness. The stuff itself, the matter, might eventually evaporate away entirely, leading to a truly empty cosmos in the far, far, far future.
Wow. It's like everything has this incredibly slow-motion expiry date. That phrase, the inexorable passage of time, suddenly feels very, very cosmic.
It does, doesn't it? It really highlights the transient nature of existence on the grandest scale imaginable. Everything we see, everything we are, it's all temporary in the grand scheme.
And if you want to, dig into the actual research paper details, the study was covered over on SciTech Daily. Worth a look.
Definitely. So the key takeaway here is this potential shift. A universe where even the densest star remnants, the things we thought were forever, might not be. This Hawking-like evaporation could mean the universe as we know it, filled with stars and galaxies, truly has a finite lifespan.
Which really makes you pause, doesn't it? I mean, if absolutely everything on that ultimate cosmic scale is destined to fade, how does that change the way you think about, well, right now, about the value of this moment and everything in it?
Yeah.
Yeah, something to ponder.